Okay, can see here, right? Okay, so for this chemical formula, okay, the first part, okay, we need to know the chemical symbols of elements. Okay, this one is found in the periodic table. So like what we mentioned, periodic table is split between metals and non-metals. The left side of the zigzag line, they will be all metals. The right side of the zigzag line, it will be non-metals, but including hydrogen also. Because hydrogen looks like it's on the left, but it's actually under non-metals. Okay, then there's actually another group called transition metals. Okay, so this one is actually between the group 2 and group 3. If you notice a periodic table, the middle portion, here that is under transition metals. They are still metals, just that they are not in any of the group. Okay, so just to take note, we look at the bottom. So like what we mentioned about formula, okay, if you have your positive ions, they are called cations. So how to know what is their charge? Actually, the group already tells you. If it's group 1, you notice that the outermost electron is all 1. So during bonding, it will tend to give away 1 to get the stable electronic configuration. Okay, so all the group 1, you notice here, they all put +1 charge. Okay, then all the group 2 is a 2 plus charge. Make sure the number comes first, then the positive charge. All the group 3, if it's metals, it will be a 3 plus. Okay, other than that, if it's transition metals, this one you have to do a little bit of memorizing. Okay, but if they give you Roman number already, like iron 2, iron 3, straight away the 2 will be a 2 plus, 3 will be a 3 plus. Okay, the thing about transition metals is they can have many different charge. That's why they are not in any of the group, because the group is only that one charge. If let's say you have like zinc, so zinc you have to memorize. It is only a 2 plus charge. Okay, so they will not give you the Roman number 2. Okay, they will only give you the Roman number if there is more than one charge for the element. Okay, so for zinc you must memorize. For silver also you have to memorize there is only a +1 charge. Okay, so this one need to know. If you look at the bottom, there is this common polyatomic positive ions, meaning it is not just an element, it is a compound. The whole compound has a charge. So those that you need to memorize, especially is this ammonium cation. Have to memorize that the formula is NH4 with a plus on top. Okay, so this one really need to memorize. Okay, if it's negative, so same thing. Group 5 will give you the 3 minus charge. Because group 5 already got 5 outermost electron, they'll just take in 3. Okay, so 3 minus. Then group 6 is a 2 minus. Group 7 is a minus. Okay, then common polyatomic anions that we need to know, those that is in a group not found in a periodic table. Okay, you can highlight. Hydroxide have to memorize is OH minus. Okay, this one must remember. Nitrate is a NO3 minus. Okay, sulfate is a SO4 2 minus. The 2 is actually on top, on top, 2 minus. Okay, the carbonate is a CO3, then a 2 minus on top. Okay, the phosphate ion is a PO4 with a 3 minus on top. Okay, so have to memorize those, especially those that I mentioned. Okay, then if we are going to do the chemical formula of the ionic compound, because ionic is between a cation and an anion. So that is when, remember I mentioned last week, the crisscross. Okay, so how to do the crisscross? Always write the cation first, then the anion, then you copy down the whole of the A, copy down first, then you take the opposite number. If it's a 3, then you put a 3 at the bottom. Then you copy down the whole of the B. Then if it's a 2 at the charge 2 plus, then you just bring down the 2. So your formula will be A3B2. Okay, which makes sense because if A give away 2 and B take in 3, you need 2, you need 3 of A to tally up with 2 of B so that you can get give away 6 and take in 6. Okay, so that's where you get this formula. So this is actually an easier way to get your ionic compound. So you don't have to think of the tallying up thing. Okay, but only applies for ionic. Covalent cannot because you don't have cations inside covalent. Okay, so if they give you an example like potassium chloride, so potassium is K plus, chloride is Cl minus. When you crisscross, it's 1, 1. Both 1, you don't need to write. Here it's just KCl. Okay, if you have magnesium oxide, so magnesium is a 2+, then oxide is the oxygen, is 2-. So you crisscross, you get Mg2O2. If both are 2, you can become simplest form, MgO. Okay, you must write the simplest form. You cannot write this Mg2O2, it will be wrong. Okay, if you got iron 3 sulfide, so iron 3 straight away is a Fe3+. Then your sulfide is sulfur. Okay, so you look at your periodic table, it's under group 6, so it's a 2-. So when you crisscross, you copy the Fe, take down the number 2, copy the S, take down the number 3. Okay, if it is calcium nitrate, so calcium is your 2+, nitrate is your minus, NO3-. So how do you crisscross? You bring down the Ca, take down the opposite number 1. Okay, then you take down the whole NO3, because NO3 is your initial B, the very general, the whole thing, take down the whole thing, NO3. Then you bring down the number 2. Okay, but why we need to put a bracket? Because if you put 2, it will look like O32. But the 2 applies for the whole of the B, the whole of the NO3. So you need to put this bracket with a 2 there. Okay, so therefore it looks like that. Okay, so maybe I give you some more examples. We look at your okay, so maybe example, right? If you have Fe 2+ and SO4 2-. Okay, so how do you write the formula? This is iron 2 sulfate. Okay, because there's a 2+ there. So when you crisscross, you bring down the whole Fe, then you take down the opposite number 2, then you bring down the whole SO4. Okay, then the opposite number is actually 2. Okay, then you notice 2 and 2 both is just 1:1 ratio. So this one actually you should just write FeSO4. Okay, then if let's say you have maybe between potassium and carbonate, CO3 2-. So bring down your K, take the opposite number 2, then you bring down the whole CO3, the opposite number is 1, so no need to write. Okay, so this is more examples. So far, okay? Okay, just let me know.